Good morning to everyone. I'm Dr. Sumiyamas. The topic of my today's class is Norton's theorem from network theorems of electric circuit analysis. On completion, the students will be able to define Norton's theorem and solve problems on Norton's theorem. Norton's theorem. This theorem states that any two-terminal linear network or circuit can be represented with an equivalence network or circuit which consists of a current source that is placed in parallel with a resistor. It is also known as Norton's equivalent circuit. A linear circuit may contain independent sources, dependent sources as well as resistors. If a circuit has multiple independent sources, different dependent sources and resistors, then the response in an element can be easily found by replacing the entire network to the left of that particular element with Norton's equivalent circuit. The response in an element can be voltage across that element, current flowing through that element, or power dissipated across that element. Norton's equivalent circuit resembles a practical current source. Hence, it is having a current source in parallel with a resistor. The current source in the Norton's equivalent circuit is the Norton's equivalent current, or simply Norton's current I. The resistor in the Norton's equivalent circuit is called as Norton's equivalent resistor or simply Norton's resistor R. Methods of finding Norton's equivalent circuit. There are three methods mainly used for finding Norton's equivalent circuit. Based on the type of sources in the network, any one of these methods can be used. Method 1. Steps followed to find the Norton's equivalent circuit when only independent sources are present. Step 1. Consider the circuit diagram by opening the terminals with respect to which the Norton's equivalent circuit is to be found. Then find the Norton's current I by shorting the two opened terminals of that circuit. Find the Norton's resistance across the open terminals of the circuit as in step 1 by eliminating the independent sources present in it. Norton's resistance will be the same as that of Thevenin's resistance. Draw the Norton's equivalent circuit by connecting Norton's current I in parallel with Norton's resistor. The response in an element that lies to the right side of the Norton's equivalent circuit is obtained. Method 2. To find the Norton's equivalent circuit when the sources of both independent type as well as dependent type are present. Step 1. Consider the circuit diagram by opening the terminals with respect to which the Norton's equivalent circuit is to be found. Find the open circuit voltage V across the open terminals of the above circuit. Find the Norton's current I by shorting the two opened terminals of the above circuit. Then find Norton's resistance R by using the formula open circuit voltage divided by Norton's current. Step 5. Draw the Norton's equivalent circuit by connecting a Norton's current IN in parallel with the Norton's resistance. The response in an element that lies to the right side of the Norton's equivalent circuit is obtained. Quiz questions on Norton's theorem. Define Norton's theorem. Write down the steps to obtain the equivalent circuit of a given network applying Norton's theorem. Thank you.